Hi students, this is Mr. Yao. Today we are going to start a new unit. This lesson may be a bit long, so please bear with me. This unit is going to be called vectors. Today's lesson is the introduction to vectors, which involves quite a bit of definition. But before we do that, let's review something we have learned before. Pythagorean theorem, which is a squared plus b squared equals c squared. The distance formula is it happens when you are given 2 points. For example, when you are given the point x1, y1, and the point x2, y2. The reason we didn't emphasize on the distance formula was because previously you have been just using the coordinate system with 2 points and form the right triangle, that way to find the distance between like these 2 points. That's what you have been using. But now we are kind of giving a formula for it, and it is basically a squared plus b squared equals c squared. In this case, it is that squared plus that squared that equals to d squared. The reason we have the square root is because we got to take square root on both sides, so the d squared would just become a d. So it is quite similar to the Pythagorean theorem. It basically comes from the Pythagorean theorem. And we will use that formula to do things a bit faster. For b, what does magnitude mean? If you remember 2 years ago, we had an earthquake. If you listen to the news, it would say like an earthquake with a magnitude of say like 5.2, 5.3. So magnitude basically means size or the level of something. Here in math, it represents size or length. Next, scalar. We have learned about that word in the last unit, scalar multiplication for a matrix. It would just mean a matrix times a number. So scalar would just mean a number. C, a compass for directions. Typically on a map, we would say up north, down south. So that's kind of how the compass is on a piece of paper. Left would be the west and right would be east. Last, D, simplify the radicals. This is where something you have learned for quite a while ago, but you will still need again next year. The reason we are reviewing this is because when you try to find a distance, or for example, when you try to find a C in Pythagorean theorem, this time around, we're not going to just round them to decimals. We are going to simplify the radicals. If you don't quite recall, here's what it means. We are going to make something called factor trees. So basically that means I'm taking apart a number 98, which becomes a 2 and a 49. The reason I start with a 2 is because 98 is an even number. And when we say we are breaking apart the number, it basically means find 2 numbers, which look like the branch for the trees, find 2 numbers that would multiply together to get you the 98. So that's how we are taking it apart. Now the 2, if you keep going, that's just going to be a 1 and a 2, which doesn't do anything. But we can still break down the 49, which becomes a 7 and a 7. Now to rewrite that whole thing, we have 1, 2, so it's just going to be a 2, times we have 2 7, so it's got to be a 7 square. Now, since that is a square root, that means we are looking for pairs under this sign. It's called a radical sign. This symbol is called a radical symbol. We're looking for pairs under there. We don't have a pair of 2, so we are going to keep the 2 inside. But we do have a pair of 7, and when we are taking out a pair, they become one number. So that 7 squared would just become a 7. And that's how we simplify it. Next, square root of 24. I would suggest you pause right here and try to practice by yourself and then come back and check the answers. Now for 24, break it down to a 2, then 12, then a 2, a 6, then a 2, and a 3. So if we want to rewrite it, that would be a square root of 3 2's, that's going to become 2 cubed, then times a 3. But this is square root, so we are still taking out pairs, even though we have a triple of 2's. In a triple of 2's, we can only take out one pair, so we have a 2 outside. But we are still left with a 2 inside, because it is a triple. We take away a pair, there's still one left. Then the 3 doesn't come in pairs, so we still have the 3 left inside. Whatever is outside and whatever is inside, we are going to multiply them together. So the 2 stays outside, the inside is 2 times 3, which is a 6. So the simplified version is going to be 2 square root of 6. Next, 500. It's still an even number, so we are going to take out the 2, then 250, then 2, then 125. Well, it's ending with a 5, so it's got to be divisible by a 5, then 25, and 5, and 5. So that, if we rewrite, is going to be 2 squared times 5 cubed, because we have 2 2's and 3 5's. 2 comes in a pair, so we're going to take out the 2. 5 comes in triple, so we can take out one pair, but we will still have a 5 left inside. That is going to simplify to be a 10 square root of 5. So these are my simplified version for these numbers. The 7 square root of 2, the 2 square root of 6, and the 10 square root of 5. That is simplifying the radicals. Now let's get to the definition for vectors. Vector in comparison to scalar. Scalar is a quantity that measures only magnitude. So basically that means we need the number. We need to know how fast something is, so 70 miles per hour. We need to know how heavy something is, 50 pounds. As for vector, well, this is actually the link to the YouTube video, the YouTube clip of the movie Despicable Me. It's exactly how vector, the character vector in there, defined himself. It's a quantity that measures not just magnitude, it measures magnitude and direction. So for example, we're not just looking for how fast, we're also wanting to know where is something going. So 70 miles per hour south, or 50 pound of force at 90 degrees. That's what we are trying to, that's what we need for vector, a direction and magnitude. Next, the representation for vectors. These two on your paper would be the bold letters. That when it's printed, we can use that to represent vectors. However, in handwriting, we can't exactly bold them. So we are going to need the arrow to indicate their vectors. You can use one letter to represent a vector, or if you have points given, you are going to use the point to actually represent the vector. We can represent vector geometrically using a directed line segment, which in other words, an arrow. Initial point is the point at the tail of the arrow, and the terminal point is the tip of the arrow. So think about it. Typically, you wouldn't draw an arrow drawing like that first and then go backwards. We wouldn't. We would just start at a point, draw it, and then put the arrow down. That's why the tail is the initial point, and the tip is the terminal point. The direction, of course, is going to be from the initial point to the terminal point. And to draw a vector, you gotta start from the initial point and end at the terminal point with an arrow indicating the direction. The few words that we have been repeatedly writing or mentioning in this paragraph will be the word initial, the word terminal, and the word arrow. That's just saying you gotta have the points labeled and you gotta draw the arrow to indicate the vector. Next, after we talk about the direction, magnitude of vector. We typically use this symbol, which looks very similar to the absolute value symbol, or you can do the double bar around the vector. Either way, that would represent the magnitude of vector. And we are going to need to use Pythagorean theorem or distance formula to represent the magnitude of vectors. Here is the first example. Draw the vector from point A to point B, and then find the magnitude. Initial point, of course, is where it starts, so 0, 0. And terminal point is where it stops, so 4, 3. 0, 0 is right here, that's point A. 4, 3 is right here, that's point B. I can draw an arrow from A to B, but also that vector is vector A, B. Now I need to find a magnitude. Basically, how long that AB is, or in other words, what is the distance between point A to point B. So, notation, don't forget that. It's going to equal to, let's have a look. We do have a right triangle. Think about it. When we first learn how to find a distance between 2 points, that's what we do. We kind of draw the right triangle and then measure the size. So for a 4 and a 3, that's basically my little a square and little b square. I'm trying to find my c. So it is going to be square root of 4 squared plus 3 squared, which is square root of 25. In order to simplify these radicals, you cannot just cross out the square root and the square. You gotta calculate what is inside first and try to simplify the radical after. You can't type the whole thing into a calculator because we're not looking for decimals. We're looking to simplify these. Sometimes, yes, you may get an answer, but a lot of times you would just get a decimal, and that is not what we're looking for. In this case, square root of 25, that's just 5 and 5. So a pair of 5s simplifies to be a 5. Because the vector above has its tail at the origin, it is said to be in standard position. This is the standard position. Next, let's define about congruence. Two vectors are congruent if and only if they have the same magnitude and direction. So let's say we have a vector here, and we have a vector in a different location. They would have to be pointing exactly the same direction, and they have to be the same length for them to be called congruent. It doesn't matter where they are. These two are going to be congruent, even though they're in different locations. It only matters how long they are and in what direction they are pointing. Next, a bigger example. Draw the following vectors and find a magnitude. There is a typo. It shouldn't be JK. It's not Joe. Just kidding. It is actually IJ. So let's draw these vectors. First, A. A is at 1, 1. B is at 3, 4. So I can draw my AB. A, B, vector A, B. Okay, I can find a magnitude. A, B. This is going to be right here, the little right triangle. I'm not going to draw every single right triangle. That will make me have like too much drawing on here, which is not clear. But I'll show then the first two. So, the first two. A, B. That part is a 2. That part is a 3. So that means I need square root of 2 squared plus 3 squared. And again, you are calculating out what is inside first and just put it inside the radical sign. Then you can simplify. So 2 squared is 4, 3 squared is 9, together that's 13. But they are still under the square root. And then you can try to start think if you can make a factor tree with this number. 13? No, you can't. So the answer would just be square root of 13. Next, C, D. C is at 2, 0. D is at 0, negative 3. So I can draw my C, D. That's my D, that's my C, that's my vector CD. And clearly this would be my rectangle right here. It's also a 2, 3. So magnitude of CD is going to be square root of 2 squared plus 3 as well, 3 squared as well, which is going to be square root of 13. Again. Next, E, F. Let's start with E. E is negative 4, negative 3. So E is right here. F is 0, 3, which is right here. So I can connect them. Then I may find out the right triangle I'm looking for. That part is a 4 and that part is a 6. So the magnitude for EF is going to be square root of 4 squared plus 6 squared. That is 16 plus 32, which is a 50. 16 plus 36, and that is going to be 52. Now I can actually do my factor tree to 26 to 13. That will give me square root of 2 squared times 13. Since we have a pair of 2, I can take it out, so 2 square root of 13. That is EF. Next, GH. G is at 3, 1. H is at 5, 4. So I can have my, I forgot to label, that's F, that's EF, and I have G and H, and that is GH, a vector. And the right triangle is 2 by 3 again, so GH would be square root of 2 squared plus 3 squared, which is square root of 13 as well. Lastly, we have IJ. My I is negative 1, negative 2. So right here, I. And my J is negative 4, 2. That is my J. I can connect them. So IJ, I can find the place, the length, the magnitude. So IJ is, if you look at the right triangle, that is a 4 by a 3. So it is going to be a square root of 4 squared plus 3 squared, which is 16 plus 9, so square root of 25, which is a 5 and a 5, so you have a pair of 5s. That is just going to be a 5. That is the magnitude of IJ. Moving on. Well, actually, before we move on, look at the notes and try to complete the following statements about similarities and differences. Then come back and check the answers. Now you can check. AB and CD have the same magnitude but different directions because they're basically pointing. Oh, I actually pointed it wrong. CD is actually pointing the other way. It's from 2, 0. So that is my C, and that is my D. I actually did it backwards. That is what CD is. You can see the arrow is pointing to the opposite direction as AB. So they have the same magnitude but different direction. AB has the same direction as EF and GH. AB is right here, EF is right here, GH is right there. You can see they are clearly pointing in the same direction. Another way to tell is all of these vectors are parallel. Next, AB and GH have the same direction and the same magnitude. AB and GH have the same direction and the same magnitude. IJ is the one that's on the left side, that's kind of crossing, and I just realized I forgot to draw the arrow. So let's add on the arrow. I is here, J is there, so the arrow is pointing this direction. But it does not have the same direction or magnitude as any of the other vectors. That is example B. Moving on. Please note that sliding a vector around doesn't change the magnitude or direction. It works just like when we did translation, because you can move a shape around without changing it, any feature about it. So because of this, we can slide any vector so the tail is at the origin. That is basically saying even if you have a vector here, well, I can move it. So now it's just going to be a vector right there. As long as they point to the same direction and they are still the same length. So all we need to know is where they start, because they may all start from the origin. And that leads us to the idea of component form of a vector. Component form is useful because it allows us to write a vector using only two pieces of information, a horizontal component and a vertical component. And the component form looks like, this is called a pointy brackets with AB inside. So it looks kind of like the ordered pair, but on your Chromebook or computer, you can just use the less than symbol and the greater than symbol to actually type in A, B. A is the horizontal component and B is the vertical component, just like how X and Y works. They kind of work the same way. Now, this is actually a very useful concept. A lot of you may take physics in the future. Whenever you take physics, a big unit would be about Newton's law. That means you have a force and you are going to take it apart into a horizontal portion and a vertical portion. It kind of work the same way as a vector. Of course, in the future, it's going to involve trig, but that's the basic idea. Component form from 2 points. Given these 2 points, x1, y1, and x2, y2, if we want to find a component vector, it's going to be x2 minus x1 and y2 minus y1. It has to be in the specific format. It's basically terminal minus the initial. That's how it's supposed to be. And if you recall this, when we learned about using formula to find slopes, this is basically what we did. We did y2 over y1 over x2 minus x1. That's actually how we found slope. So this is very similar, but it has to go in this very specific order. Now let's have a look at some examples. Example 3, graph the vector b equals to square, well, pointy bracket 5, negative 3. This is why the component form is super easy. We have defined component form after we have learned we can move the vector anywhere, so the tail is just on 0, 0. So this only provides us with 1 point, which is at 5, negative 3. Well, that's because the other point is going to be 0, 0, so I can just connect them, and it's easy as that. Of course, this is vector b. Next, example 4, same thing. Negative 1, negative 4 is going to be a point right here, but the other point is just going to start from the origin, and that is going to be same thing labeled as vector b. That's example 3 and 4. Moving on, draw the vector given the points, find the magnitude, and then write the component form. Let's do that. My point A is negative 2, 3. My point B is 1, negative 1. So I can connect them. And then it's time to find the magnitude. Magnitude is where we are going to use the Pythagorean theorem, the right triangle. That is a 3, that's a 4. So that means my AB is going to be square root of 3 squared plus 4 squared, which is a 5. That is the magnitude. Lastly, we need the component form. So we can just start writing the vector. Here's something you got to be careful with again. You got to use the terminal point minus the initial point. The terminal point, of course, is the letter on the end. So the terminal point is 1, negative 1. That means it's going to be 1 minus negative 2. It's the x values that subtract each other. So 1 minus negative 2. This is where a lot of you made mistakes when you first learned about slopes. Well, learned about using the formula for slopes. You gotta be very careful with the signs. So that is the x. Next, the y is negative 1 minus 3. It's going to need to be from the terminal point to the initial point. The terminal point is where it stops. It stops at b. This is going to give you a 4 and a negative 3. That is the component form. Next, example 6. Let's first draw it. There's a typo. It shouldn't be AB anymore. It should be CD. So let's draw it out. My point C is -2, -1. My D is 2, 4. So let's connect them. And that is going to be the vector V, or actually not vector V, vector CD. Okay. After that, we are going to draw the right triangle right here. That is going to give us a 4 and a 5. So we can find the magnitude of CD. Square root of 5 squared plus 4 squared. 5 squared is 25, 4 squared is 16. Add them together is a 41 under the square root. Again, we're not typing the whole thing into the calculator. We're not trying to get a decimal. So you need to calculate it inside first, and then put it under the square root, see if you can simplify that radical. But in this case, 41, you can't break it down, so it's just going to be square root of 41. Then we have the component vector, vector CD, and again, you gotta start from the terminal point. The terminal point is a D. It stops at the D. That is where the tip is. So 2 minus -2, 4 minus -1. Oh, should be component form with pointy brackets. So 2 minus -2 is a 4, and 4 minus -1 is a 5. Now here's something you may have noticed already. In my triangle, I have a 4 and a 3. Well, these are kind of related to the two numbers, a 4 and a 3. That is exactly what's happening. Because I've said the formula of component form looks very similar to the slope. Think about it. If you're trying to the slope from point A to point B, a 4 going down, that would actually mean, I actually wrote it backwards. I just realized that. A 4 would actually be a -4. So that is a -4. Then going to the right by 3, that's why it's a +3 for x. Here, it's going to the right by 4, so +4. It's going up by 5, so it's a +5. That's how this works. Some of you might be like, well, can I find the component form and then do the magnitude? Sure, totally fine. You can use these numbers, find the magnitude. The only thing I need to emphasize again, which is something I've emphasized at the beginning of the school year, whenever you have a negative number, you gotta put it inside parentheses. So for example, this one, if you want to use that, you are gonna need to do 3 squared plus -4 inside parentheses and then squared. That can make sure you square it correctly. And that -4 with parentheses around is going to be a 16 plus a 3 squared. It's still going to be a 5. So that's example 5 and 6. Now the very last bit. Since we have already mentioned about component form being in the formula, being a part of finding the distance or the magnitude, here's what it is. The magnitude of component form. To determine that component vector, we can use the distance formula because now it's kind of special. The component form only gives you one point. That's because the other point is the origin. Component form, kind of the default is you are moving the vector, so the tail is at 0, 0. That's how we can think about the component form. That's how we can think about the vectors. Now, as you can see in the formula, I did emphasize to make sure you have the parentheses around the two numbers, especially when they're negative numbers. So example 7. Find the magnitude. That is going to be square root of 5 squared plus 12 squared. That is going to be square root of 25 plus 144, which is 169. For that number, if you want to use your calculator to test things out, you do need to test quite a bit, like test the 5, see if you can divide. But since it's 169, it's got to be the number that's at least bigger than the 10. So in fact, it is 13 and 13. So basically that is 13 squared, which is just 13 for the magnitude. Example 8, for vector u, that is going to be a square root of 7 squared plus 3 squared. That is going to be 49 plus a 9, which is square root of 48. Again, calculate the inside, write it under the radical, see if you can simplify that number. 58 can be broken down into a 2 and a 29. There's nothing we can use to break down 29. So these would be the numbers, which means we can't simplify it. So the square root of 58 would just be the answer. That is everything for intro to vectors. Hopefully that clarified things about the magnitude. But I'll see you next time. Thank you.